Good morning. Good morning. My name is Naveen Girishankar. I'm the president of the Economic Security and Technology Department here at CSIS. Great to have all of you join us for today's program. We're launching our latest report, Growing Challenges in the Semiconductor Design Industry, another great collaboration of Sujai Shivakumar, Chuck Wessner, and Thomas Howell. I don't think it could have come at a better time. I think many of you have heard news of breakthroughs in quantum chips by Microsoft and Amazon and Google, and we are at a moment where we can't forget that the chip agenda is not simply about manufacturing, but also importantly about design, and an area where the U.S. has an important advantage and one that we think will be important to continue to maintain. Our department focuses on economic security and technology. And I think, previous Secretary Raimondo said it best, sort of in the last few weeks of her time in office when she said that it's when in respect to the export control agenda, it's not simply around that, it's also about out-innovating others. And that couldn't be, more important than when it comes to the question of chip design. Technology innovation, commercialization, scaling is at the heart of long-term economic security. And so I just really appreciate the work that the Renewing American Innovation Program has done under the leadership of Sujai and with the partnership of many of the people here. Today's conversation is going to be very interesting. The report is a launching off point, but to hear from industry and our colleague from NatCast will be really quite interesting. So without further ado, again, congratulate the team on keeping us focused, eyes on the prize, and I'm going to ask Sujai to come on up and get the program started. So thank you very much.
Good morning, and to those of you who are in the room and to the much larger audience that is online currently. So very happy to release the report today on growing challenges for the semiconductor design industry. And I think the second part of the title is something that we really should keep in mind. We really cannot keep our leadership in this area for granted. So Naveen talked a little bit about the Economic Security and Technology Department. We are an integral part of this department, and we have work going on in a number of domains. Today's meeting, for example, is focused on the issue of semiconductors and national security. We have a meeting coming up in Syracuse in a few weeks, looking at the issues of workforce in semiconductor manufacturing. We continue to have a major program on standards and intellectual property rights. We have an event on April 1st, our annual leadership conference, looking at issues that are important to IP and standards. And we have new work. Also, we are looking at a new program in quantum. We'll be looking at our challenge. Our work is really focused on how do we make sure that innovations in quantum are rooted in U.S. in the United States, looking initially at the Boulder quantum cluster and then looking further to what's happening in Illinois and other parts of the country in terms of how these ecosystems are building and connecting across. And finally, some new work, which is really excited about, which is on the future of bioinnovation. Semiconductors and our biopharma industries are probably our two largest and most innovative industries. And it's really important that we make sure that the United States maintains its leadership and the advantages that come from that leadership in these major technologies. So, this is the report. Happy to commend it to you. And in the spirit of the bottom line up front, here are the four major points. The U.S. semiconductor design industry is critical. And the U.S. at present is the global leader in every segment. But the design industry is facing a growing challenge from Chinese firms, which are backed with really significant state support and gaining global market share at the expense of U.S. designers. And the United States needs to respond to implement a range of policy measures to support our continued leadership. I don't need to perhaps inform the group in front of me in terms of why design and national security are so tightly connected. It provides advantages in terms of military preparedness, in terms of cybersecurity, in terms of leadership in AI and quantum, among other areas. We are currently a dominant present in design in terms of our IDMs, the fabless companies, the OEMs, the EDAs, and the IP providers. And I'm really happy to see that we have folks from AMD, NVIDIA, Qualcomm, as a part of the group that'll be discussing how the US can maintain its design dominance. But as I mentioned earlier, there are some clouds in the horizon. The US design firms are not market leaders in every semiconductor design product segment. There are challenges certainly to the talent pipeline, and of course there's growing competitiveness of Chinese design companies. And as you can see, the US has been losing some market share, and this is projected to continue. There are, of course, China is making significant advances in chip design, driven by their government's determination to transform their company's design sector. Massive resources are being committed to this effort at the national, regional, and municipal level. And while aggregates hide a multitude of sins, you can see some of the impacts in terms of the number of chip design companies that have burgeoned over the past few years. And you can also see that in terms of the acceleration, this is just over the past few months in terms of technologies that have been announced from China. So there is this imperative for U.S. design leadership, and I think our policymakers do need to recognize the strategic importance of chip design sector and the unprecedented challenges it faces. Chip design is the highest value additive stage of semiconductor fabrication, and our leadership represents a huge economic and strategic advantage for the United States, which we really important that we preserve. So what policies are needed? We need to increase investment, we need to grow and keep the talent pipeline, and we need to expand tax incentives to make sure, among other policies, to make sure that we remain in the lead. And to discuss these and more, I'm happy to introduce you to our panel of experts. Charles Wessner is a professor at Georgetown and a very esteemed and dear colleague and advisor to our program at Renewing American Innovation. He will be leading the discussion. We have Mariam Cope, who is Vice President of Government Affairs at NatCast. Grant Gardner, who is the Director of Government Relations and Regulatory Affairs at AMD. Falan Yunug, Director of Government Affairs at Qualcomm. And last but not least, Eric Beckenfeld, who's the Director of Technology Policy at NVIDIA. So if I can invite you, gentlemen and lady, to come to the panel. Thank you so much.
Chuck, you pick.
I'll take it.
I'll stand at the podium. Oh, there we go.
Thanks. So we'll try and make this as interactive as possible. Looking around the room, I recognize that a lot of people here already know a great deal about the subject. But I think, as Dr. Shivakumar pointed out, the design industry is both a great advantage for the U.S., but it's also something that other countries aspire to. To try and put a more positive tone on some things, that technological advance can, of course, help the world globally. When we do things better and there are investments made in research, that has a positive sum outcome. But we also have to recognize that there's a global geopolitical competition, and an essential, indeed core element of that involves competition for the high ground of fundamental technologies for the modern economy, but also the promise of future growth and future capabilities. And so I'd like I'm pleased that we've had a positive reaction to our report on the challenges facing the design industry, but I'd like to turn to some of my colleagues here with what I hope isn't too self-serving a question, but it is, what did you like about the report? And we'll later on get to see what might be added to the report, or where there's a need for future work. Perhaps, Falan, you could perhaps pick up a first reaction. You had something to do with the origins of this report.
Yeah, so first of all, I want to thank Csis for inviting me to this panel with our illustrious panel mates. And I also want to thank you guys for doing this report, Chuck, Tom, and Sujai. I think underscoring the importance of chip design is something that I think we understand as part of the industry, but I think maybe not many outside of the industry. So I think so the report gets a lot right. I would just highlight a few things. One, the importance of chip design is something that I think needs to be underscored over and over again, right? The chip ecosystem is complex. There are many pieces to it. But as the report mentions, 50% of the value add created within the whole ecosystem is created in the chip design stage, right? That's double more than any other single stage of design, stage of production. So that's a really important point that I don't think many people in the world know, and even policymakers, right? So important to underscore that, which the report does really well. Number two, I would say that the U.S. semiconductor industry has design leadership is another really important point that the report underscores. Again, this is something that is super important because of the high value of that particular activity. And knowing that the U.S. has this leadership now is an important point to underscore. And thirdly, I think what the report does is underscore the need for maintaining that leadership, right? I think we've seen what's happened in the chip manufacturing space over the decades, where we had this leadership and that we don't have that leadership. I don't think we ever want to be at that stage with chip design, given how important it is in terms of its value. So doing things now, while the U.S. industry has leadership, I think is super important. I think that's really what the main message from my point of view is of the report.
Well, I think that's great. I think it's a very valuable message. We have a tendency in this country to wait until the industry's in the ditch before we decide to, at great cost, to try and pull it out. And trying to maintain excellence, like a good football team or a good soccer team for our European friends, it's that type of constant maintenance. Marianne, what is your assessment of where we are?
So, in terms of the report, I have to say it does a fantastic job of laying out some of the fundamentals that's driving this global competition. So clearly, China is investing heavily in semiconductor design. They're following a playbook that they have followed in the past, as Falan alluded to, which is produce as many folks through their talent pipeline as possible, publish as many papers as possible, offer industrial subsidies, and encourage domestic procurement. And so all of those items stack together to create a pretty formidable amount of growth in the design space in mainland China, and I think the report lays that out really well. I think what Falan has pointed out is also really important, is that this industry did start in the United States just as the semiconductor industry did. The fabless industry has generated tremendous economic growth for the United States, and that's only poised to grow very significantly. And manufacturing is an important component and part of Moore's Law, but even the manufacturers themselves will admit that just pure scaling and pure manufacturing prowess is not going to be enough to push us into the next generation of AI chips, the next generation of Moore's Law or hyper Moore's Law, whatever you want to call it. You really need design to be able to win that race. And so I think the importance of making those investments, similar to what China is doing, here in the United States, support for R&D, support for workforce, support for our domestic ecosystem is incredibly important.
Well, I think those are very important points, that there is a playbook, and it's one that has worked and is working. I think you raise very important points about both of you about the scale of Chinese efforts, both in talent and in funding, and it's I think hard sometimes for the policy community to appreciate just how different that is. There's also something, Eric, I'll turn to you next, but I think one of the great things about capitalism is it provides discipline and expenditure, and it weeds out less successful ones. On the other hand, it's sort of like being in a wrestling match where one party can't really be thrown out of the ring. If they lose, they get state support. If they win, they get state support, and no one is terribly concerned about quarterly results, at least in the early days. But how do you see the report? Where do you see value added there?
Yeah, I think it's really important to understand that the U.S. leadership position isn't a sort of guaranteed by destiny feature, but rather a feature of how good design is done and how the ingredients of the U.S. and allied systems feed into that. And what I specifically mean is, good design comes from three ingredients, or three pillars, I guess you could say it rests on, which is having a good design workforce, having good design tools, and having revenue that flows into supporting design work. And the revenue in the system that the U.S. has sort of cultivated, revenue comes from global sales of commercial products. And that's why the commercial sector has far outpaced the defense sector in design of capable microelectronic systems. The defense sector had a head start. I mean, the defense sector cultivated this industry first, which is great. I'm not saying that they did anything wrong. The defense sector never had a hold on the destiny of microelectronics because they were never going to pursue volume. And volume is what was proven out to be the driving force behind the best designs, because volume equals revenue equals reinvestment back into the design cycle, and that's how you get good designs, as long as you have the other ingredients as well. And so it's very challenging to compete only relying on government subsidies. So it's very hard for a government-supported company that doesn't have international sales to really spin that design cycle. And that's where I think the urgency actually starts to become really visible now, whereas, and I really like the historic look at the share of international design, where you might rewind 6 years and confuse yourself into thinking, China's not going to compete in this space. That we don't have to worry about that. And you can look at the numbers, and you maybe even be forgiven for confusing yourself into thinking that's not a risk. But you only need to look at how many smartphones Huawei is selling internationally right now. And it's a technology platform that rests on domestically designed chips, increasingly domestically manufactured chips, as their partnership with TSMC is being shifted over to a partnership with SMIC. That's the magic that spins this cycle that creates the best designs. And so this idea that the U.S. must have the best designs because the history of the industry's here, that's not why you'll have the best designs. I mean, it's a nice thing to have had, but the more and more we cede the international market to Chinese firms, most especially Huawei, I think the less we should expect to have design leadership. And that is not something that if we cede that government action that says, oh, well, we'll supplement R&D a little bit, or we'll give you a tax break. None of those actions can make up for if we lose the international market.
You know, Eric, let me pursue that just a second. I think you're on the one hand, you're entirely right. It's worth remembering, by the way, that the Defense Department and other elements of the American government were instrumental in the Apollo program and the Minutemen program. And the Apollo program took chips from $1,500 a piece to $15 from 62 to 68. And I think it's worth underscoring that people say just let the government get out of the way. It's not exactly how we got here. James Fallows, a journalist I've always admired, remarked once that we seem to have forgotten the playbook, and that the close interaction between government procurement and private sector ingenuity has been instrumental. The other thing is, when you mentioned the international markets, I'd like to touch a little later on the question of export controls. I know that's not important to any of you, but if it were, you might have an opinion. But let me, but to illustrate the state issue, markets in important countries in the world with vast markets can be closed by fiat. And of course we can do some of that here, but certainly not to the same degree. So I think we may want to talk a little bit about some of the trade issues that overhang this. But Grant, if I could turn to you first, what is your take on a company like AMD certainly has some views.
Yeah, Chuck, number one, I found the report very refreshing. I feel like it was timely. If you look at where in just the last decade or so, kind of the re-engagement of the industry by and large in the U.S. government, spanning from the first Trump administration through the Biden administration, and here we are today, I kind of view at a top level, the industry is learning what it means to be regulated. The government's learning what it means to regulate this industry. And there's been successes and mistakes kind of over the last decade. I think your report lays out a very critical aspect that if you were to go from the beginning of the CHIPS Act during the Trump administration when it was authorized through the NDA, it's almost fascinating to me to go back and look at that bill and go, man, the U.S. government had so much learned. And working in the Trump administration, going back and reading it, it was almost like a very, not elementary way. It was thoughtful, but the size and scope of where the industry is and the pace that things are moving and where companies are positioned. AMD, even a mere 7 years ago, was a quarter of its size as a company. So just to show how fast this technology is moving, your report is, I think very timely. I think highlighting the scope and scale of the cost of design is absolutely paramount. I think that gets lost on policymakers pretty regularly. Miriam mentioned, or I think it was Falon, who mentioned on the 50% of the cost. It is, it's always fun to sit up with competitors, but there is a way, an analogy that we're on a treadmill and we're racing and you can't stop. And the minute you stop or you take a break or you step off the treadmill, you fall behind. And it's nearly impossible to catch up. And so at AMD, we try and find solutions and policy that allow us to run faster, allow us to compete fairly. That's anything from export controls to regulatory policy to, we love the enthusiasm from the Hill. There's been a lot of bills introduced over multiple Congresses around semiconductors and educating offices on, what does it mean? Allow us to go compete fairly where it's needed. And finding ways, I think the piece too in your report that I want to just close with on this section is on national security of design. Our companies, if you were to look at AMD on our classic x86 processing, the United States has had a vast lead in that space between us and Intel for a long time. There's also been ways that the interoperability of our chips and how they compete with each other, we compete as companies very fiercely. There's plenty of stories about that. But for our end customers and then the users and the technology that floats between those, I think has led for decades was a U.S. leadership across semiconductors. And so what does the paradigm shift look like moving forward? I think those are going to be kind of the big questions that we are faced as a country and as the government and as the industry moves forward in new interfaces and new operating systems and new code. I think will be kind of the biggest challenges we face on maintaining leadership and then supporting the sheer cost that it takes to run faster, especially versus global competition.
Can I pick up on something
Sure.
that my colleagues have mentioned? So the whole idea, I think, of R&D needs to be underscored because it's really, when I think about the ingredients, Eric mentioned the ingredients that goes into designing a cutting-edge chip today can cost multiple millions of dollars, almost into the billions at the cutting edge. The key ingredient for me is R&D investment, and that stems to sales to overseas markets. But anything to help the U.S. industry and the design companies invest more and incentivize them to invest more in R&D, I think is a recipe for success, right? Qualcomm, we invested $9 billion last year in R&D, which was about 22% of our total revenue. I would imagine at AMD or NVIDIA, that R&D intensity is similar. It has to be done, and we cannot shortchange the amount of investments we reinvest back into R&D to be competitive, right? So I think that key ingredient, and it's not a secret, right? That's the playbook, right? You have to invest a ton in R&D. We've done so. The U.S. industry has done so for many years. But doing even more of that will be key, and creating policies to incentivize doing more of that, I think, is also the key for that long-term leadership in design specifically, because design is so R&D intensive.
Well, analytically, I fully understand that and endorse it. But let me ask you a question that I mean constructively, but I also mean it to be tough. So we've got 3 companies here who are absolutely phenomenally successful and becoming more so. And so the thing is, we need to tell the American taxpayer, but because you're making so much money and doing so well, we need to cut your taxes. Now, that's the tough question. I don't think we often get questions quite so analytical, and I think there's an answer to that. But the answer would be, I think what you're saying is that...
Yeah, personally, I think it all gets back down to competition, right? You have to, in order to be competitive, and I would say, there are many different industries out there. Policymakers clearly have identified certain ones, and I would say the semiconductor industry is one that is very important, qualitatively more important than maybe some other industries, right, from their point of view. So why wouldn't you do everything you can to be sure that leadership is maintained by the U.S. industry, right? And for companies such as our companies, that leadership really stems, as I mentioned before, back to R&D investment. So as it relates to incentivizing more R&D investment, that's where I think it's important to, from a competitive point of view, to be sure that that is done.
And there's a national security element, but...
Right. I'm very eager to comment on this R&D piece of the discussion. I think that what we're seeing now is that now that the CHIPS Act has accomplished moving a significant amount of semiconductor manufacturing onshore to the United States, with the projections looking very positive for the next 10 years out, policymakers are now realizing there's not just a manufacturing supply chain, there's a innovation and IP supply chain, and that's what the R&D feeds into, and that is a global supply chain. So it's really important when you look at what the industry is doing to understand that some of the research that's happening in the private sector is incredibly critical to that innovation supply chain, but what I would describe it as is big D, little r. Whereas what's happening in the national labs within the National Semiconductor Technology Center that is continuing to be set up that I work for is big R, or the National Science Foundation. And you need both pieces of that supply chain, not only to accomplish the research, which oftentimes requires very unique, very expensive infrastructure, which to date, we do not have in the United States in a significant way, the way Europe and Korea and Taiwan have. But you also need to have the companies be able to take that research and develop it. And that requires a tremendous amount of investment, as Falan said. So we need really all pieces of the innovation supply chain onshore here in the United States if we want to begin to catch the tail of the tiger here when it comes to competition with China.
Well, there is that two-pronged approach. On the one hand, you do need the public R&D, and that has to be financed somehow. And then on the other hand, one of the great assets now in the U.S. competition are companies like yours, which are able to invest vast amounts in literally both cutting-edge products, but because of the nature of the industry, actually cutting-edge research. So it's quite a different thing.
So Chuck, I want to circle back on the tax piece really
Please.
quick. Number one, on design, roughly 80% of an R&D expenditure for a design company is the salaries of our engineers. And at AMD, our most valuable asset are our engineers. If you were to look back on where Congress was in the passage of the CHIPS Act, one of the pieces that was left off was a credit for semiconductor design, advanced design in the United States. We don't need to revisit reasons why, but I think one of those areas is the American engineer globally competitive from a cost basis? And since the first passage of the CHIPS Act to where we are today, countries around the globe have taken a very focused effort on building out their design centers. I mean, the presentation earlier was how many thousands of new design companies out of China. Right. India, on their own, has roughly a 50% tax credit for semiconductor design activity. Not to mention, other friends and allies, which is all great. But I think the question is, where does innovation occur, and is that occurring in the United States? And not that a single tax credit is the silver bullet that's going to solve any of these future problems, but it is one aspect that we would view as very important. From AMD, the products that we create, there isn't a minute of any American's day that they don't wake up to the minute they go to sleep that they're not running their digital life through an AMD product. We have one of the broadest portfolios of products delivered to multiple markets. It's not just your PCs, and it's not just your gaming systems. It's the data center. It's traditional data center. It's AI. And then it's also our FPGA offerings, which I always appreciate when someone takes the time to actually write about FPGAs in DC. It doesn't happen nearly enough.
You might explain to the public what FPGs.
Well, all right, liberal arts degree, so hopefully it's all liberal arts degrees out here as well. It is a field programmable gate array. It is a chip that the end user can reprogram to have you do or function in any way you see fit. So really critical for telecommunications infrastructure. So picture, instead of going from 4G to 5G, you'd have to tear down all the base stations and antennas across the United States to then put in new ASIC chips. Instead, you have FPGAs that are in there, and you can update the firmware pretty regularly. So that's one example, but also really critical for aerospace and defense, medical devices. And I think, as we continue to see scrutiny in our supply chain, whether it's post-COVID or from national security, from malign actors, one of the areas that we view is having control of the IP as U.S. companies and driving that innovation in what is actually getting designed into the silicon is absolutely paramount. I think one last piece on why U.S. leadership in design and a tax credit is helpful to run faster. And I know you're going to get to export controls, and so I'll do a little teaser. The minute U.S. companies are not in the lead on the bleeding edge of technology, export controls mean nothing. The minute that there is a foreign country with a foreign player who has advanced leadership in GPUs, CPUs, it doesn't matter. The ability for the United States to control where those products go, and this doesn't mean export controls are perfect, but they mean a whole hell lot less if there is a foreign leader and a foreign company is leading, because the United States would have a very hard time controlling that. So all of these things are kind of put together on scales, and how do you balance those scales moving forward, which is always a challenge for companies and for the government from my time when I was at Commerce as well. So.
Well,
Now I want to dive into I'll make this fast, and I just want to, because I wanted to touch on the question. Questions of tax is one tool in the toolbox of how you assist or harm. And if I were to think of the tools that the design sector most relies on, that the government can start to tug on, let me think back to maybe the past 5 years. What's the state of where we're at? Research expenses from the U.S. government are the lowest they've ever been as a percentage of GDP. I say that, I think we're going to go lower. So that seems to be the direction that we're headed in right now. So they were the lowest, and maybe they'll go lower. H-1B success rates are the lowest they've ever been. So our workforce is more constrained in the design space than ever. International students as a percentage of graduates at the advanced degrees for electrical engineering, material science, physics, chemistry, higher than they've ever been. And so combine that with low H-1B success rates, it's a real attack on workforce, right? So our R&D diminishing, at least the share that comes from government revenue, workforce diminishing, export control, international sales, do fewer of those. So, I wouldn't say that tax is what must be done. But my point is there's lots of tools you can consider, right? There's workforce enhancements. There's government investment in R&D. There's tax. There's allowing international sales to take place. Every single one of those is under attack, right? The last rule that the outgoing administration put on export control was a limit on almost the entire world. And so it doesn't have to be tax, but eventually you've exhausted all possible tools because of questions of policy. And so what other ways do you have to buoy an industry that you want to maintain leadership in?
yeah, there's some of us who sometimes think that we're very carefully dismantling the underpinnings of how we got here. And the lower government investment is one. It doesn't match yours, but it enables yours, and you take that out.
Maybe
Please.
I can talk a little bit based off of Eric's comments about the CHIPS Act investment in semiconductor R&D, because I think that's incredibly important to this discussion. So the National Semiconductor Technology Center was authorized by Congress to deal with pushing forth next generation semiconductor R&D here in the United States. One of those priorities is design, because of its importance in pushing Moore's Law forward, its importance in these various national security applications, it's important in communications leadership, so if we want to be globally competitive towards Huawei. So the National Semiconductor Technology Center has a couple of ways of helping the design industry. One of them is our Design Enablement Gateway, which is actually not necessarily meant for large, robust companies like AMD and Qualcomm and NVIDIA to come in and do their designs on, but it's those small startups that can come in and use the same infrastructure that the big companies use to develop next generation technologies. Now, how that benefits a big company is they suddenly have a new ecosystem of startups that they can tap into. That's new talent, that's new technologies, and it's de-risking those technologies. We also have a series of manufacturing infrastructures that are closely tied to R&D, so you can run a full wafer line in between Arizona and New York. And part of the reason that's also important is the design companies can also take a look and see, for their very, very experimental R&D that their corporate boards don't want to approve, they can jointly form joint ventures with the government, with our experts, with national labs, with DoD, whoever wants to join, and they can actually generate data enough to figure out whether or not it's worthwhile to take this type of R&D into their company. And so that's a very significant investment from the U.S. government. Is it enough? That's another question altogether.
Can I just pick up on the importance of the CHIPS Act that Miriam alluded to?
By all means.
You know,
Although leave some time for some of your other pressing concerns.
sure. I just think it's really important because the CHIPS Act was historic in that it addressed two really important pieces of the challenge that we face with the U.S. semiconductor industry. So it was very ambitious. One, the question of resilience, where manufacturing is done. I alluded to that earlier, that the effort to try to build more of that in the U.S. is an important priority for policy point of view. But the other point, which Miriam talks about recently, was just talked about, is the R&D piece. And tied to that is the importance of helping to develop more high-skilled workforce in the U.S., right? So one of the first centers of excellences that the NatCast started was the Workforce Center of Excellence. And I think that was really important, a really important signal to the industry in terms of the priority of what the R&D component of the CHIPS Act, the $11 billion that's focused on R&D and high-skilled workforce, has really underscored the need for developing that workforce. So it all kind of relates. As Grant mentioned, a big share of the R&D funds goes to hiring the best and the brightest. It's all about what we have up here in terms of design, right? It's not capital intensive the way that manufacturing is. So point is, we're doing the right things in terms of policies that were initiated under the CHIPS Act on the R&D and the workforce side of things. We just have to be sure to push them through. I would wager, maybe after we're retired in 20, 30 years, and when we look back at the CHIPS Act and figure out, what dollars really paid off, right? I would imagine the $11 billion that was invested in R&D and workforce in programs like NatCast will be high return dollars when we look back and say that really paid off.
Well, that's also an argument for why you need a multi-pronged approach. I'd look forward to conducting that study in 30 years to see how it...
That's what we guys can do.
But I think we've touched on two things here. And I'd very much endorse the workforce component of CHIPS, but to refer back to our Chinese colleagues, there's a question of scale and continuity. We have a rubric here of substantial and sustained funding, and I think that's a challenge going forward. There's also potential, just to throw out there, for enhancing existing public-private partnerships through CHIPS or other organizations to, in the 80s there was a major effort to increase the production of semiconductor engineers, and the private sector stepped up, and then in a coalition and consortium, and then got the federal government to continue. And either in that format or in another one, it's very important that it's basically a call, as your public policy facing organizations, that the companies have to step up too. And stepping up that way is a great way of justifying, I think, in a policy framework, why some of these measures to provide substantial investment tax credits should be made. The other, of course, is just, I'm glad you raised the H-1B visas. Do you have any thoughts? We have some about national security carve-outs, but trying to sort out the high-skilled, high capital-intensive talent with these unique design engineers and separate that from problems on the border, that these are wildly different things.
And the other H-1B is a contentious one because I think...
I'm sorry, I can't.
H-1B is a contentious one because I think the public, it doesn't have to be, but the public has this idea that it's something used by big tech firms to drive down wages in their industries. And I think if you look at the semiconductor industry, that's just very clearly untrue.
Right.
And I've seen some of these infographics that rank compensation of H-1B visas. And I think it's clear that there are some industry segments that use it as a way to drive down wages. But all of the top 10% of H-1B by compensation, that's all semiconductor firms, right? So the semiconductor industry is not using this as some way to put downward pressure on the wages of their engineers. They're using the H-1B process because it's a pathway to get the workforce that's being trained in the universities in the United States. That's the fingerprint of graduate students in the United States, right? it's just a reality of who's pursuing these degrees.
Well, just briefly, would you concur that that one of the choke points we've installed on our own system is not being able to bring in globally qualified engineers to support?
Or bringing them in just long enough to get a degree and then saying, starting now, you're on your own, good luck.
Yeah. The president of the National Academy of Sciences a decade ago said that for PhDs in STEM, when the degree is awarded, there should be literally a green card stamped to it.
And I'll note, by the
otherwise,
way,
you're just funding the competitors.
they don't necessarily leave our companies. They just don't work in the United States, right? So what starts to happen, which is certainly what has happened with NVIDIA, but I'm quite confident that it's across the semiconductor industry, is, well, now, you try to hire them in the United States. You have them here for a period of time because their visas, their temporary visas can get extended. You try the H-1B process. It fails once, it fails twice. Okay, well, now we have an office in Israel, we have an office in India, you can go work there. It's still good for the company, but it does harm the innovation ecosystem of the United States, right? Because having them here adjacent to our educational institutions, that's what creates a vibrant innovation ecosystem. So our companies can still benefit, but we all benefit a little bit less when we have to ship them internationally to places where they're then able to work.
I think that you say that very well. And if did you want to add to that? Otherwise, I'd like to go on to your favorite topic, which how many of you favor for tighter, more stringent export controls? Is that something that you were?
Well,
for the audience, I would point out I'm saying that with humor.
So before we jump into export controls, I just want to highlight what Eric is speaking to. The U.S. has seen a significant decline in domestic U.S. students wanting to study in the semiconductor fields. And that is part of what our Workforce Center of Excellence is directly aimed at, is can we make sure that we increase the domestic pipeline of students looking to work in the semiconductor industry and get those advanced degrees that the industry needs. However, that takes time. It takes 5 years, it takes 10 years to really get a big pipeline there, and we don't have 5 years. Companies don't have 5 years to get their R&D programs going. They can't pause, and so they really need to be able to do that R&D, and it is a global competition for the innovation supply chain, really.
Well, I'm not looking for affirmations of company policy here, but I do seek your views. The 8 years is a long time, but you get trained engineers by starting to train them now. And one question could these tax incentives include programs for scholarships funded by the companies? One of the things that the Siemens top executive mentioned once is that they do really excellent working training because they are encouraged by their tax code to do so. And perhaps we could do something more like that, plus the consortium that we were discussing. And of course the opportunity that NatCast represents, where companies can come together and develop common programs. But above all, there's always a training element in that. And I raise that because it doesn't look like the government in the near term is going to take major initiatives in this space, which was the case 30 years ago also. And so we can A, complain, or B, do something. And we have a bias in our program here to B.
So Chuck, I think one thing that does get missed, especially in DC around workforce policies, sometimes even at some level, and what NatCast is doing is amazing, and their support of the states and the initiatives with universities and around is spectacular. But there are states that are really taking the leadership position. Whether that's states like Arizona and Texas and New York and the programs out of Purdue that have really leaned in. And one example is working with in Texas, working with AMD to help develop the new curriculum for ease of access to what it means to be a design engineer. And that's anything from tutorial courses at an undergrad level to mini bursts to see if it fits that student's curriculum or if they're more interested in it. that the barrier of entry is much lower. Well, they asked us, being like, what is it that you would like to see? And you didn't have to have that conversation in Washington. That was a conversation that was done in Austin. And so that connectivity of what does the student body need? Who are the largest employers around the state? Well, AMD is one of those. We've been in Texas since 1979. So we have a vested interest in the success of Texas. And so those are the examples on workforce policy is at some level it's cede some of the ownership to the states and the universities and the companies that are operating those localities, because you're going to see more of a tailored reach and use without having to come through here where it gets stuck in the bureaucracy and everyone becomes a faceless student.
Yes.
So I do think that there's been some really encouraging efforts that, by and large, AMD has been very, very pleased to see. I think that ROI will take some time. Again, we recruit very, very advanced engineers. So,
Well, I think that's an excellent example. In fact, emphasizing the state role where there's a self-selection rather than trying to impose nationally. And there again, for consideration, there's maybe a positive cost share that can be done, and opportunities for your engineers to lecture in the schools. I mean, that is inspirational as well as providing the kind of tacit knowledge that just isn't in the textbooks. But I do think that's a positive sum area with the NatCast Catalyst can help promulgate these best practices and will, I'm sure.
Yeah, and I'll just add in there that semiconductor development programs, if you're looking at careers in the semiconductor industry, they do require a fair amount of infrastructure. You need design software that's expensive, you need clean rooms if you're going further into the clean room space. So this is something that we've heard from across various states that they had to make those investments. NatCast is making those investments, companies are contributing. So you have to have a sustained investment in the infrastructure that surrounds these workforce programs.
I think that's a very good point, and sometimes we slight that. But how about just a quick word on your favorite topic of export controls? We note in the report we refer to the calming influence of trade and this disturbing tendency we have seen where we act like we can just decouple this incredibly complex global ecosystem of commerce. I think we forget sometimes now that we can produce some of these advanced chips here in the U.S. And if I'm not mistaken, Miriam, the first thing we do is ship them to Malaysia for packaging, is that? And after that, they may well go to China to be put in a telephone. And from there, they come here. And I think it's very important to understand that complexity is one of the reasons for the success of the industry, that global interdependence. But do you have any comments that you feel like making publicly, and I understand if you don't, that on the current export regimes or concerns about future regulation?
I'll say just from AMD, from a principal level, it's not a private company's role to say what's of national security importance or not. True. I mean, and I think if you start there with a level of understanding that is the U.S. government, and there are experts in that field who have a critical role to play. I think the role for industry is to come around core principles of where you see problems. And in my personal view, export controls should be administered fairly. They should be administered consistently and with transparency. And if you have kind of those three pillars, as regulators work through that process and engage with industry on, what is the impact, what is the scope, you can lead to successful outcomes through export controls. Doesn't mean it's fun, doesn't mean it's like the greatest meetings of all time, but I also think you can have that balance of what the U.S. government views as a national security importance without overly impacting American companies, or picking winners and losers through export controls. And that there are growing pains through all of this. I think an area where export controls can be more effective is if they're more directed instead of expansive. And so there's been a recent change in expansive export controls, whether that's countrywide or in recent months worldwide export controls. It becomes very difficult to control or administer or enforce a rule of that size and scope when you're talking about the ubiquitous of semiconductors. Right. We make hundreds of thousands, if not millions, depending on the product line of these, and the supply chain is large, our customers are large, and BIS is underfunded, and how do you actually enforce all of these when you're doing a very expansive rule? So those are kind of like the broad pieces that we look forward to working with the Trump administration on finding the right path forward that allows for U.S. leadership and dominance for many years to come.
Well, I think you raise an important point on the expansive nature, and there's also some experience in government myself asking. It's important to get some outside analytical assessment at times. Asking a government agency, is what you're doing working? The answer is, oh yes, of course, and we just need more resources, or we need to make it broader. And I think, again, with some humor but some accuracy, that if I understand it correctly, these chips are pretty small and pretty transportable, and your market is global. Well, all I can say is, perhaps with respect to Russia, it's amazing how much Georgia has been absorbing in terms of semiconductors recently. And I think we just have to recognize the permeability of the global economy, and the running faster, working harder at making ourselves more functional may be the longer path forward.
Well, pulling for one moment on just the thread of how insight is provided to government on what might be expected to happen in industry, right? So I think it's absolutely correct. It's not necessarily the role of industry to be telling the government how to balance national security concerns. We don't have the experience, we don't have the knowledge, right? So I think that's absolutely correct. But I think what I would hope is helpful is that industry certainly does have the insight and the knowledge and the experience to predict what actions might result in follow-on industry actions, either from US companies or even perhaps from Chinese companies. And so I would at least hope, and we're already very, very eagerly working alongside the Trump administration and are certainly happy to continue to do so. I would hope that the capabilities outside of the United States are not underestimated.
Right.
I think it was a great point that was brought up earlier, I think by Grant, that if we don't design the best chips in the United States, then export controls don't mean anything. They only are meaningful if the world wants to buy our chips, and the world wants to buy our chips if we make the best chips. And to underestimate international, or to be far more pointed, to underestimate Chinese capabilities can easily lead you down an incorrect path of assessment on what you might expect to happen.
Well, Eric, is also an important point. They don't have to buy the best chips. They only have to be able to acquire good enough chips. And as you go on, the good enough, you can argue Huawei doesn't make as good a phone as Apple, but half the world is buying Huawei phones.
And people seem to think their phones are pretty good these days.
Yes, no.
And I would actually, the topic of this is design. I would also and have in more private conversations, encourage the government not to over-focus on manufacturing node. Design is a way to make systems better, and so is packaging, and so is software, that is parallel to manufacturing process. Manufacturing process is one way to make platforms better. It has happened to be the cheapest way to make them better over the last 60 years, but it's not the only way. And it's becoming increasingly expensive, and we're certainly in a period of diminishing returns for manufacturing process making systems better. So Just because someone's constrained to 7 nanometers or 5 nanometers or whatever that might be, doesn't mean they can't make competitive chips.
Right. I think that's a profound point. Did you want to just close off? Because I think we're actually... We have time? Okay, well, please.
So I just want to point something out about Eric's comments, which is that the problem really becomes severe when they don't even want to copy us anymore. And we see that now in the electric vehicle space with China.
Right.
And we want to make sure we don't end up in that space in the semiconductor industry, particularly in the semiconductor design industry. And so I just would urge policymakers to really focus on running faster, because that gives us room to be able to make policies. And when we start falling behind, then you have way fewer policy choices than you might have if you were at an advantage, technologically speaking.
And your point about the ingenuity of the small companies and absorbing that into the ecosystem, the points about broadening improving our immigration system, but also improving our domestic training. And we're great believers in incentives here, so drawing incentives for companies to do that training, and your point about encouraging the development of state-based initiatives in cooperation with industry are all avenues forward. Above all, we need a portfolio of approaches and recognize that the competition is going to increase, not decrease. And so I hope we can help generate some support for what is unquestionably a crucial industry, both for its dynamism, for its opportunities of economic growth, for consumer satisfaction, and not least because it's critical for our national security. And we absolutely have to make clear that some of this commercial success translates very directly into our security capabilities, and design is literally instrumental in that. So with that, I hope we can get together for another discussion like this before too long, and we look forward to your inputs into things that need to be taken up here in the interests of the American economy and the security of its population. So, thank you very much.
Thanks, Chuck.
Thank you.
Thank you. That was just great.